So we're going to be taking a look at problems to do with, well, basically in context, so solving for some sort of word problem situation, and these are going to result in quadratic equations that we have to solve. So a really important skill here is to be able to visualize and actually draw a picture of what they're talking about. It can be quite helpful for a lot of the problems. And you will be required at times to draw on other knowledge that you might have, such as the area of a triangle or the formula for Pythagorean theorem, things like that come in handy as well. So if we take a look at a first example, the length of the rectangle is 8 more than the width and its area is 48 meters squared. Find the length and width of the rectangle. Well, if we visualize ourselves a rectangle, we've got a length and a width, and we're saying that the length of the rectangle is 8 more than the width. So if I call the width x, how would you write 8 more than x? Because the length is 8 more than the thing that we don't know, our width here. Well, you could say here that this is x plus 8. And so one thing that we would want to do is say that the width, maybe I'll write that word, the width is equal to x, just so we know what those variables mean, and the length then would be x plus 8. You could have used a w for width if you felt like it, and that would be fine as well. So we know the area, remember the area of a rectangle is just equal to the length times the width. So in this case, our area is going to be equal to our length, our width, doesn't really matter which way we write this, but we'll just say x times x plus 8. So remember, when you write a number or a symbol in front of a bracket, there's an invisible time sign between those. So we're saying the width times the length here, and that should give us an area. And we know that that should be equal to 48 meters squared. So now we're going to try and solve this. And so you need to remember for quads, when you're solving, you need to get it set equal to 0 first, and then factor it. So in this case, it's already factored, but we can't solve it because it's not equal to 0. So what we need to do first is expand it out and rearrange. So x times x is going to get us x squared, and x times positive 8 will get us plus 8x, and this is equal to 48. So now we're going to rearrange to set it equal to 0, so I'll go minus 48 from both sides. That gets me x plus 8x minus 48 is equal to 0. And then what we need to do now is factor it. So we're going to end up with 2 brackets because I can see this is a quadratic, and I need to think about what times this to 48 and adds to 8. So here I could have 1 and 48, 2 and 24, 4 and 12, what else? 6 and 8. And these are all factors of 48 that will times to get you 48, and out of this combination, what's the pair that has a difference between them of 8 potentially? And that would be the 4 and the 12. They have a difference of 8. So if I watch my signs, I need to times together to get a negative 48, so I know one of them needs to be negative, and one of them needs to be positive. So if I call this one the 4, and this one the 12, if I put the negative with the 4 and the positive with the 12, when you add those together, 12 minus 4 is going to get you the positive 8. And again, it's that idea that if you do have a negative and a positive in the brackets, whatever sign is in the middle of your term here, in this case positive, I want the bigger number to also be that sign positive. So that's my factored version here, and now I need to solve these, which means I have to set both of these equal to 0. So x minus 4 is equal to 0, and x plus 12 is equal to 0. Rearranging, we get x is equal to 4, or x is equal to negative 12. Now, because quadratics give you 2 answers, sometimes we've got to pay attention and see if both of them make sense or only one makes sense in this case. So if I said that x is supposed to be my width, and I told you that I'm making a rectangle of width negative 12, it would probably make no sense at all, because you cannot have a distance or a measurement that's negative for a length of something or a width of something. So what we would say is width equal to 4 meters, because cannot be a negative number. So the width is equal to 4 meters, and then that would make my length equal to 8 plus 4, because we knew it was 8 longer than the width. Maybe I'll write that the same way as the equation there. That's, well, the width plus 8 will give us the length, and that's 12 meters. So there we've answered the question to find both the width and the length, not just solved the quadratic equation, but answer what they're looking for, both the width and the length. And I've made a decision about whether or not it's possible to have a negative solution. And here in this case, because we're talking about the actual width of a triangle, we can't have a triangle with width negative 12. It makes no sense. So, again, as you're going through these, draw yourself a picture. It can be quite helpful. You might have to call on previous knowledge, such as the area of a rectangle. And keep in mind that it must be set equal to 0, and then you have to factor it and solve it. And if it's not equal to begin with, make sure you expand it out, get it equal to 0, then factor it, and then solve it.